All right, we are moving on with some of our material for our physics course. We're still talking about speed and average velocity, average speed and average velocity. So let's kind of review some of the things that we've talked about. Characteristics of speed. Speed is the rate of motion. Okay, so rate of motion. Speed is always positive. Okay, because speed is distance over time. We can't have a negative distance and time can't be negative. And it gives us no information about direction. This is scalar. Scalar only has a magnitude, has no direction. Okay, the greater the speed of an object, the faster it moves. That makes sense. All right, what about characteristics of velocity? Velocity gives us both the rate of motion, okay, similar to speed, but it also gives us direction. And that's why this is called a vector. Okay, vector quantities have a magnitude and a direction. The sign of the velocity gives us the direction of motion. So when we have a negative, that just means it's to the left or whatever direction we decide that negative is. The magnitude of the velocity gives us the speed. So if I'm traveling to the left at negative 5 miles per hour, okay, traveling to the left at the speed is 5. So you just take the absolute value and you have the speed, okay? So don't get stressed about that. The magnitude of velocity is simply the absolute value of the velocity. So when we talk about the magnitude of the velocity, just drop the direction. I don't care about north, south, east, west, positive, negative. So for example, if the velocity is negative 2.5 meters per second, it has a magnitude of 2.5 meters per second, and that is also its speed. Okay, or its instantaneous speed. I said average there, but anyway. All right, so which object has the greatest speed? 1.5, 2.4, 1.5, negative 1.5, negative 2.5, and those are all in meters per second. And if you were to answer just based on the fact that, oh, well, maybe B because it's a positive 2.4, you would be incorrect because I asked for the speed. So you got to take the magnitude. So just drop the negatives, don't think about the negative, and think about, okay, which one's traveling the fastest? Which one's traveling the fastest? Don't worry about the direction. The negative is just the direction. And in this case, the one that's traveling with the greatest speed is the 2.5 meters per second to the left, assuming left is negative. Okay, so we're continuing on. An object moving in a positive direction has a positive average velocity. An object moving in the negative direction has a negative average velocity. All right, I have a couple problems I'll work for you quick because we're kind of finishing up on speed and velocity. Number 22, I believe, in your book. It's probably in the actual within the chapter. 2019, Usain Bolt of Jamaica set a world record of 9.58 seconds in the 100-meter dash. So the distance was 100 meters and the time was 9.58 seconds. What was his average speed? So speed equals question mark. So there's my knowns and there's my unknowns. And I know that speed is equal to distance over time, and I'm going to solve for that. So speed is equal to 100 meters divided by 9.58 seconds. And that would give me, what's my problem? 10.44 meters per second. If I wanted to pay attention to sig figs, 100 only has one sig figs, and I would actually have 10 meters per second. Okay. Now they also wanted the value in kilometers per hour. So let's take 10 meters per second. Okay. 1,000 meters is equal to 1 kilometer. King Henry died drinking chocolate milk, right? So I know that I also need to get it into hours. And so I know that 60 seconds equals 1 minute. How did I know the 60 seconds goes on top? Well, because my seconds has to cancel, and I can see my meters cancel. I'm getting closer. Currently, I have kilometers on top. I still have a minute, though. I want to get rid of that minute. And so I know that 60 minutes is equal to 1 hour. Now my minutes cancel and I'm left with hours on the bottom. And then I take everything on the top and multiply it and then divide by 1,001. So I will find that my answer is, I get 36 kilometers per hour. Okay. Let me double check because I'm extremely tired and I could be making mistakes. Divided by 1,000, I get 36. All right, so this is just converted to kilometers per hour. Okay, next. A train travels, now this one's tricky, okay? I already know how most people would try to solve for it. Okay, a train is traveling in a straight line at 20 meters per second for 2 kilometers. So I'm gonna draw a picture of my train. He's traveling at 20 meters per second for a total of 2 kilometers, okay? Then he travels, so then at some point in time, he then travels another 2 kilometers at 30 meters per second. What was the average speed for the 4 kilometer trip, excuse me. Now, most people would probably say, well, he's traveling at 20, then he was going at 30, that equals 50, and then I'm gonna take that, divide by 2, and that would give me 25 meters per second. And that would be incorrect. And the reason why is because the amount of time that he spent at 20 meters per second and the amount of time that he spent at 30 meters per second is different. He traveled that 2 kilometers at 30 meters per second. He completed that 2 kilometers in a shorter period of time because he was traveling faster. So how would I solve this problem? How would I determine that? Well, what is the definition of speed? It's the total distance over time. Now, the total distance that was traveled, we know, is 2 plus 2. We have a total distance of 4 kilometers. Well, what was my total time? Well, we can find out, right? We can solve for time, I'll do it in green, at each location. So if I rearrange this equation for time, I would find time to be equal to distance over the speed, okay? And so let me just move this out of the way. Let's solve for the time for each location. So this is equal to the distance, which was 2 kilometers, divided by 20 meters per second. So I'm going to flip that second back to the top, and I'm going to have to do some conversions, right? 1 kilometer is equal to 1,000 meters. And now I get everything cancels and I get seconds left. And then I find that to be equal to 100. I find 100, right? Yep, I get 100 seconds. Okay, now I come over here and I do the same thing. I know that speed equals distance over time. I'm going to rearrange that equation for time. Time is equal to d over s, and then I find that t equals that distance, which is 2 kilometers, divided by the speed, which is 30 meters. I'm going to flip that second back to the top, okay? And then I'm going to say 1 kilometer is equal to 1,000 meters, and I find time to be equal to 66.67 seconds. Okay, so there's my time for each leg. So what was my total time? It is equal to 166.6 seconds. We don't round until the very end. Okay, now I was asked to find my average speed. So the speed is equal to the distance over time. What was the total distance? 4 kilometers divided by 166.67 seconds. And then I'm going to convert. So let me move that out here. I get 1 kilometer equals 1,000 meters. So I take 4 times 1,000 divided by 166.67, and I get this average speed is 23.99. So how many sig figs should I have? This has 3, this has 3. Technically, I have 1, and I could be at 20, but I'm going to just say, again, even in AP Physics, we don't have to be 100% accurate on sig figs. So I would say 24 meters per second. Now it's pretty close, but this is technically the correct way to determine average speed. Okay. I hope that makes sense to you. That's the only material that I have for today. We are moving on to position versus time graphs, and we will be utilizing some of Mrs. Query's lecture as well as flipping physics for those. He does a great job of explaining that. So I hope that makes sense, and come see me if you need help. Thank you.